Alright, let's get back to it. Next up, I'm going to do the x86, yes, x86 implementation, because currently it only works for 64-bit. Here we're getting the value if we are on a 64-bit process or not, and if we're not, we just return and just quit. So instead of doing that, I'm just going to comment that out for now. So now it runs on 86 processes as well, but of course this is not going to work. This is gonna crash, probably. The two things I need to do to make it compatible, I think, is this function needs to have a second version. If x86, then we do this, and for now let's do nothing for the other processes, because my bigger concern right now is the mitigation flag offset. As I understand, there are two offsets, one for 64-bit and one for 86. But hey, Cronsby. But god damn it, I lost my thought. I blame Cronsby. It's all his fault. Well, I don't know if that means that that the offset is different for a 64-bit OS, or if it's different for a 64-bit process. Maybe we can find out. Windows kernel PE process. P process x86. Maybe. EP process, of course, not PE. E process. E process. Yes, that one. I always say PE because that's portable executable, but that's not what's meant by that structure. Sizes and offsets from Microsoft symbol files, blah blah. Contain type information. Sizes are straightforward, even without symbols. Yes, yes. Code having not changed. Set offsets, names, but on types known. Yes, 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 yes. Yeah, that does not answer my question. Yeah, I think I'm just gonna try. Or do I? Kyle. That's irrelevant. Oh, here we go. Original implementation, only 32-bit. Problematic, these counters. Okay, 64-bit. Yeah, I still have no idea. What about KR process? Which is the same thing, by the way. Layout. Oh, here we go. Processor dependent definitions. Yeah, that might mean that it's dependent on the OS version. That would have actually been my guess, so I might just go for that. We can also look at what other people are doing. Oh yeah, this is just offsets, it doesn't even specify. Oh, okay, this is 64-bit. Yeah, I'm pretty sure it means OS version. I'm actually so sure that I'm gonna try it. And just see if it crashes. Let's do it. So what I'm gonna do is I'm gonna print a few mitigation flags which I know the value of, or I think I know the value of, and then we're gonna see if the value is as expected. So we're gonna say like debug. Like debug. Disable dynamic code, and that's gonna be a decimal, I think, because we obviously can't print out a single bit, and it's part of a U-long bit flag, so yes, that's correct. And then this should be disabled if we're going to open Notepad on x86. So that should be 0, and then we're gonna say ASLR. No, that's always enabled. What I want is high entropy ASLR, which should be enabled. Flags. Oh, wait. Why does it think I'm instead of... oh, yeah. One too many thingies. Flags 1 ASLR. Yeah, exactly. That should be enabled. Flags 1... what else do we have? I can just open it over here. I hate how much I have to click in Visual Studio. Oh yeah, the control flow guard, that's an easy one. That should definitely be on. CFG. Control flow guard enabled. Yeah, I think that's good enough. Gonna compile it and then we need WinDBG. Also, if we don't do this, then the entry point will not be hooked, so it should be all good. Yeah, this should be non-destructive. Thanks, hope you have a wonderful day. Goodbye. And we open WinDBG, we attach. course I need to enable debug printing. We're gonna do that by going ad ntk default mask 8 and then just let it run. And now we can start. Oh yeah, we should also sc stop gi access denied. Oh yeah, of course, I need to start it as an admin because we don't want two instances, even though one is for yeah, one will be for 64 and 86 and one for 86, so it will still be two versions or two of the same driver running. I'm just opening Notepad and checking if there's any output, and there isn't any, which means that the driver is not running anymore. Perfect. And I'm just gonna open the driver loader thingy. I'm just gonna unregister it, making sure. Alright. Wait, it doesn't say driver entry anymore. That is weird. I think that the this is no longer debug, and we set debug to 8. I wonder if that's maybe just too much. Gonna try to set it to 4 because I don't want to make the kernel printing more verbose. I'm just gonna get spammed with logging, and I'm not too keen. It still doesn't show up. 3? Just playing around. Oh yeah, 3. That's weird. You know what? I'm actually going to redefine all of the logging levels because I don't like how Windows sorts them. Constant expression auto log level debug. I don't know, I'm gonna change that in a second. And below debug we need oops, we need or wait, do we put trace above or below debug? I might put trace at the top. Yeah, I'm gonna do trace debug. No. Debug trace and then info and then oh god, warn and error 0. Yeah, that makes the most sense. Then we do 1 and 2 and 3 and 4. But also we need to make the WinDBG output a bit more. Wait, no, I need to reorganize them. Trace. Oh, god damn it. Here we go. Debug trace info warn error. Yes. And Yeah, I'm gonna make the WinDBG output just a little bit more verbose so we can see the level 4. Because come on, there are like 32 levels I think, and shouldn't be too bad on 4. With the spam, I mean. Spam. Yeah, that doesn't make sense what I'm doing. Or does it? No, actually it does. Yeah, now they are all on the same height. Anyway. I only know that how we can set the mask, but I thought that setting it to 8 would be enough, but maybe I don't understand how the masking works. WinDBG. Oops. Oh god. Just gonna Google it. Filtering for each message you want to send to the debugger. Yes, yes, yes. Component name, value, yes. Value of the appropriate component filter mask. Yes. Each component has a different mask. Mask value indicates if the component's messages are displayed. You can set the component filter mask in the registry. Yeah, I don't care. Attach a kernel debugger. Values that are passed to component ID and level are compared. The value of the corresponding component filter mask. Yeah, no shit. Here we go, choosing correct level. Level parameter has a D word. It's used to determine importance of the field. Connection between level. B field depends on the size of level. What? The importance bit field. Excuse me. Level is equal to a number between 0 and 31. It's interpreted as a bit shift. Oh. Oh, of course. Okay. I see. So results in a bit field with exactly 1 bit set. Level is 0, bit field. Oh, interesting. Okay. Yeah, that makes sense. So this would just be insanity if we set the filter mask to that. I think what is being shifted is the filter mask itself. So if we do 8, that means that for the highest one, debug, the 1 is shifted 4 times. Alright, I'm gonna have to use a calculator. So we have a 1. And gonna shift it left by 4. Oh, hexadecimal. We have a 1 and we shift it left by 4. Which gives us this importance thingy. Does that mean we have to set it to 32 to see the debug output? I have no idea what I'm doing. Just gonna try. Oh god, there will be so much garbage. Hey, it works now. And there isn't even garbage. So I do understand how it works. Which is good. Undeclared identifier. Oh, yeah, of course. Debug trace info. Here we go. Should compile without issues, and it does. Oh yeah, right, I wanted to open a notepad. Wait. Okay. Wait, now I don't see... Oh, I hate this. Now I don't see the output anymore. Is it because debug was 3 and not 4? Do I need to increase it by 1? I'm gonna do 64. Yeah, that didn't work either. Why though? What was it before? Oh, I can just look it up without undoing that whole thing. I think it was 4 from the beginning. I do not understand how this works. Nope. Still no output. easy way to use the level is to always use values between yes, 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 the meaning given using the other bits to mean whatever you choose. Excuse me. Another way, explicit fields. What? Wait, what? Wouldn't that mean that if I used 4, the importance would be 16? And with a mask that is greater than, wait, no, it is then ANDed. Oh, oopsie. Oh, now I understand. So what I need is essentially, I think, minus 16. So do I have to do 31? I'm just gonna try. Hey, it works. Sweet. But now I'm curious. Does it work if I do 15. Wasn't sure if that would be enough. It is enough. But it will not be enough if I do 7. Yes, it's not enough. If I do 7, we cannot see the output anymore. So 15 is going to work because we have... So the simple explanation is we have a maximum value of 4. And if we want to see all of the levels, so 1, 2, 3, 4, not counting the 0 because that will always be displayed, 1, 2, 3, 4, then we do 1, 2, 3, 4. Each one represents one level that is going to be ANDed, which means each of these is a bit flag that says show level, yes, no. So show all 4 levels, 1, 1, 1, 1, gives us 15. Yeah, so with 15 we see each of the levels we want to see. Glad I finally understand. Alright, and now I'm just going to open... I'm first going to do that instead of a debugger, so I know what's going on. Is that not how it's called? Oh yeah, it's 32, not 86. And I'm just gonna open a 32-bit notepad. It's in Windows as well, 86. That's where the legacy 32-bit system applications are stored. And I'm gonna start the driver and reset. And we can see that we get some output. And we see dynamic code is not disabled. High entropy ASLR it's not enabled. Control full guard is though. Interesting. Because I said earlier that I expected high entropy ASLR to be enabled, but now that I think about it, I remember reading that on 32-bit apps, 32-bit system apps, it isn't. But of course, we don't have to guess. We can actually verify that with a tool called... what's the name? Fuck, what is it called? Windows CLI show mitigations? I don't know. No, that's not what I want. Why is my brain so empty today? Shut up. Oh, I remember. It's called checksec. Yes, but we need it for Windows. And additionally, to make my life easier, we can get it as a plugin. Oh, did I stop the driver? Well, now I did. Yes, that's what I wanted. We can get it as a plugin for x86 DBG, and then we can just check it inside of the debugger. So I'm just gonna find out where the app is installed, file location, and then we go to plugins and the 32-bit version. And of course, I'm just going to install the 64-bit one as well, in case we need it. 32 debug, and now if I open Notepad, and we go to plugins, check, yes, we can see that for notepad.exe we have DEP, ASLR, CFG, but no high entropy ASLR. For reference, I'm just going to show you what this looks like on 64-bit. Interesting. Oh, I did not know they would be disabled. Whatever, does not matter. Notepad, and again we do the same thing, we do a check, and we see. Oh, we don't see. Do I have to do this first? Wait, does it not show high entropy ASLR? Excuse me? It doesn't. Huh. Well, I'll just use the command line tool, I suppose. Winchecksec. So what's the dumbest way I can install this? Oh, that's, yeah, just gonna download macOS, Windows, release. I'm gonna try the 64-bit version and hope that it also works on x86 binaries. And if not, I can download the other one as well. We don't need Dio anymore. Goodbye. Build. I'm assuming bin. No, it's not in bin. Here. All build. No. Okay, where the fuck? Here we go. Here's the binary. So we do winchecksec and we do Windows syswow notepad, and we see ASLR high entropy is not present. Yes, and we can compare what we saw here. Oh god, opened a bunch of shit after that. Here we go. This is the notepad that I opened, and we can see disable dynamic code is equal to 0. We can't even see that in here, but I know this to be true. High entropy ASLR is set to 0, which we can't see. CFG is set to 1, which is also true. So I'm just going to say we're right about the assumption that the offsets depend on the OS version and not the process version. It just makes more sense that way. So we can just Wait, why are you complaining now? Excuse me? Did I mess up the macro? No. Yes? Maybe? Hello? If not status, we do print. Why are there two semicolons? That does look suspicious. Do I not do this? That might not be the cause for the problem, but yeah, it's kind of stupid nonetheless. Expected parenthesis. Where do I need... Oh, I forgot a comma. But... oh, here it is. Yes, that was my problem. The macros are hard to debug, but also without the modern C++ features, which we don't have inside the kernel, kind of stuck with macros. Yeah, gonna get rid of this, gonna keep this. So now we know that this code works well. The next step is to write this one for 32-bit, which is gonna be a long process. So I'm gonna open the hook file. Here we go. And we're gonna have to do all of this, but in 32-bit. What this is doing is it's basically it's writing raw bytes one by one to the target entry point, and those raw bytes will represent the assembly we are running. So obviously I'm writing opcodes, operation codes. And the opcodes I'm writing are first of all a jump to our shellcode, and then inside the shellcode I am doing virtual protect to make the thing executable, no, to make the entry point writable. Then we can restore the original entry point, then I'm doing virtual protect to make it executable again. And then I'm calling a load library to load our DLL, and then we are going to jump back. Yeah, that's it. Void hook32 void func and target. Oh, oopsie. Target is the place where the shellcode will be, and func is what we want to hook. And I'm considering to open a hooked process in a debugger to just see the assembly codes so we can easier oh, it's fucking loud, I'm sorry. So we can easier port them to 32-bit. I'm gonna open a debugger. And yes, here we have the notepad. I'm gonna start the driver, start the notepad once again. For some reason it doesn't show me the modifications. It says got entry point. Wait, here you go. It says got entry point, replaced entry point with a hook. But I cannot see that it did that. Oh, maybe because the debugger is only halting once, I don't know, at the original thing? What do I know? Oh right, I should start the driver. No, that doesn't work either. Would have surprised me anyways. So why can we not see it anymore all of a sudden? The address is correct, isn't it? 7FF745 404050. Yeah. The entry point is correct. Are we actually calling? We should. This should call the function. Oh, I got an idea. Let's look at where the shellcode is in memory. Because as we can see here, it prints the location. So let's just go there. And it doesn't exist. Why? Oh god, stop. Stop. Notepad.exe. Opened handle. Yes. Okay. Notepad.exe is native 1. Oh yeah, I exited here. Entry point. Yeah, that's gonna be the same for the same process, that is to be expected. The weird thing is that although we can't see it, it's still working. Because as you can see, it did get injected. just gonna quickly print out where we allocated the memory. Shellcode allocated at, and then pointer, and then shell, oh, not in caps, shellcode memory. Oops. Yeah, and then it should be stopped. It is. And then I'm gonna compile it. And I'm gonna run it again. Not used for the format string. Oh, should be lowercase. Yeah. Target unreferenced. Oh. Yeah. I'm gonna comment this out. It's not used yet anyway. And starting it again. And opening a notepad. So what do we see? I'm gonna stop it. We see that, first of all, here we go. Notepad.exe. Yes. And it allocated here. And it got this entry point. Search protocol we don't care about. Search filter we also don't. Just random processes that are opened. So, do we have anything at this location? 186C. 186C. Okay. 186C and 910. 186C 91. Here we go. Hey, that's it. That's the shellcode. Yeah. It should jump here. It doesn't. I think we are reaching the entry point after the DLL has been hooked. We can easily check if that's the case because you can see in the memory map which DLLs... Oh yeah, I'm right. It's already loaded. So we are now post-hooking. So why does it not stop before? Let's see how the call stack is going. Dispatch. Yeah, base thread init. Yeah, let's work here. We probably going to be way too early. What is Rex? Rex is worker thread. Yeah, I think we are going to... Yeah, this anti-DLL stuff. Alright. And now Where are we? Okay. Is that... No, that's not the one. Now we are getting there. Yeah, as you can see, Rex is pointing to the entry point. So I'm gonna step into this. And as we can see, it got replaced. Wait, did it? Are we? No, we are still inside NTDLL. Wait, why? Didn't we just jump to the entry point? Wait. Now I'm just hella confused. Okay, we just jumped to our shellcode from completely invalid instructions. Oh, sorry, that was wrong. Wait, it still thinks we are in here. No, because it was a jump, I assume, instead of a call. Yeah. But that's still very wild. I'm just gonna manually go back to the entry point. And we can see what the hell just happened. This is not correct disassembly. This is completely wrong. It's all fucked up. So what if I do... What if I do a set hardware and execution? What do I do? What if I do a hardware breakpoint? Alright, I should remove this. Hey, the hardware breakpoint works. I can work with that. I'm just going to always set a hardware breakpoint. So now we can step into, and we land inside the shellcode. And now I'm gonna actually stop the driver, and I'm gonna open another debug instance for 32-bit. And we are gonna go to the entry point, and yeah, this part is going to be straightforward. This is just gonna be a jump dead beef. Wait, it's actually checking? Oh, that is dumb. I just don't want it. Hey! Oh, it still does it. Okay, it's just a warning. That's fair. So we can just jump to our shellcode, which is going to be the first thing we need to do. Jump to the shellcode. Where's there an 8? Weird. But whatever. Yeah, E9 should be the correct opcode. x86 absolute jump. Oh. No. x86 absolute jump. And we see E9. Actually jump near. glad that I looked it up, because that's not what we need. We might need FF. Far absolute address, give it an upper hand. Absolute indirect. I'm just gonna do FF. Why is it not doing that? Whatevers. Jump near relative. Relative to next instruction. I don't get why people would do it like that when I can just do FF. And why /5? Sorry, I'm not too familiar with 32-bit x86 assembly. Online disassembler. And I'm just gonna do FF, dead beef. No such instruction. Okay, but E9? Oh, disassemble. I entered it in the wrong thing. Whoopsie. Disassemble. FF dead beef. Bad. So that's not an actual opcode, is it? Or am I just getting scammed? Yeah, that's not what I want. That's a jump. But that's a relative jump. What about EA? It says absolute. What? Yeah, that obviously doesn't work. Address given an upper hand. Why is it only a byte? Mania says that you can only do an absolute jump if it's indirect. Oh. Oh. I see. That's fine. I'm just gonna do a relative jump. So the first thing I need to do is, yeah, we need to store the start of the original thing, and we need to remember what the original bytes were. Save original bytes, that's what I need. Original equals Oh, and I mixed them up. I did. So target is the thing we want to hook, which is pretty obvious given the name. Now copy target, and we copy from target into func size of stub size. Of course, stub size currently is very specific to 64 bits. Stub 64, stub size 64. Yeah, that's fine. And then we need the same for 32. Oops. And what is the stub? The stub is E9 and right, we cannot hardcode the stub. 1, 2, 3, 4. That's kind of annoying. Oh, you know, it's fine. Stub is just E9, that's the relative jump instruction, and the size is the stub plus size of uint 32. Because of course the offset will be 32 bits at max. Stub size 32, and this will copy the original bytes into the hook function to save it. And then we'll have to do all this as well. What this will do is it will store a couple of strings in our hook function. It's just like a bootleg data segment I'm making, just writing some strings into the code section, and then we can reference it by the address we are storing in these variables. Yeah, we're gonna need this as well. Gonna write this later on. What just happened? Trying to undo. It doesn't let me, because for some reason the keyboard thing has changed. Yes. And I'm not gonna write that now. Instead, I'm gonna finish the overriding of the entry point. Write stub. That's what I want. So we're gonna write into the function the stub 32, and right after we're gonna write the target address, and that should be it. Now we should jump. Oh, god damn it. Yeah. It doesn't like unreferenced variables. Oh god, even more. Yeah, all we need to do right now is write the stub. Gonna start the driver and see if we have a stub. And we don't. I need to set the hardware breakpoint here. And we still don't. What does WinDBG say? Where's Notepad? This is not a 32-bit address. None of these are. Let me just run this again and see. Okay, so as you can see, it is running again. Oh no, they actually are 32-bit addresses. They are just long. Very long. Placed entry point. Yeah, let me just look at the entry point then. Oh, of course. Whoops. We didn't call the function. What a fucking classic mistake. Well, we are changing something. Yeah. That's amazing. I think the VM went to sleep and then crashed for whatever reason. Well, fuck. Oh no. And stopping the driver once more, opening Visual Studio, so where did I leave off? Right, we are writing the stub into the function. Why are we writing it into the function and not the target? Right, stub function. Target. Oh, so I did have it the right way, where the function is the entry point and the target is the shellcode. I should really change these names, because that's just confusing the shit out of me. And I'm gonna check if the stub is correct. It should be 5.9, I think. Where's the header? It should be hook.h, yes. 5.9, yes. That is correct. And we open the debugger. Hello? Oh no. Oh shit, of course. Yeah. Terminate. Yeah, we shouldn't start the driver before starting the debugger. Notepad. And we started. We restart Notepad, go to the entry point, and we did... What did we do? Why is it E8 instead of E9? $60 is the entry point. Oh right, we don't have the debugger to look at logging. Whatevs. You can just look how it's called. So it's doing hook 32, entry point, shellcode and memory. Oh. Oh, yes. That is so unfortunate. We can't use void pointers because they are 64-bit. We have to use uint32. And of course target is not a uint32, so I need to... Do I reinterpret cast? I don't, I need to statically cast it. And we know that static cast uint32. We actually do know that it can be casted to a uint32 invalid type conversion. Yeah, right, we can just cast a pointer to an integer. So if I do reinterpret cast, it should only... Yeah, it doesn't matter. It should choose the lower part. Yeah, that should be fine. Reinterpret cast, pointer, truncation. Yes, I know. Why is that a problem? Alright, then gonna do uint pointer, uint ptrt, and I'm gonna statically cast that to a uint32. Here we go. Because the static cast is checked, so I don't think it will throw... Yes, it will not throw the arrow. Which was technically a thing. God damn it. It was technically just a warning. But I don't like having warnings. That looks about right. Why are there so many Fs? Is that a valid address? FFF? It does not look right. Also, why here and not at the start? Yeah, I'm gonna have to turn on logging once again, so I know what the fuck is going on. And 15, so we can see everything. Quickly stop it so I don't get spammed. Entry point 60. That's correct. And this is a 32-bit address, which is not the same as this one. Of course it isn't. I'm making the same mistake again. But I still don't see how it's writing to the second instruction. If else. Yeah. I should also... No, whatever, that's fine. Yeah, I'm writing into the target, I mean into the function, and I'm writing the target address. So what's your problem? A9 and the step size is correct, and I'm using the correct one. Is it here? Is write bytes my problem? No, I don't think it is. Whoops. Yeah, first I'm just writing a single byte. But it's placed at the wrong address. Oh. Oh, it's not placed at the wrong address. It's not placed at all. Huh. Why are you not placed? Is it loaded? Oh no, it could be. It's not even done. So why do we not see the modification? 2F1860. 2F1860. We are attached to the process. We are writing those bytes to this function, which is the entry point. Oops. Oh. Huh. Well, that's fine, because we are modifying the address after we wrote there. It's also fine. Let's go there. It does exist. Yeah, it did get allocated. Right. Weird. So how about just writing to the function directly? Right, it's a void pointer, we cannot dereference that. Reinterpret cast, or no. Let's just do a memset. Memset function value 69 size, I don't know, 50. That's gonna completely fuck up the process. But we should see. Oh yeah, we do see it. So it actually does write it after the call instruction. Hey, what if the call instruction here gets inserted later? Can we breakpoint on read-write? Hardware on read? No, hardware on write. Because I have a feeling that this is changed after we make our changes. How about... Oh no, I have a function for that. Address offset, I think it's called. Then we just say -10. Address offset. Func is not a type name. Excuse me. Oh, of course. Type, I don't care. Void pointer. It doesn't matter. No, it should be void just because, yeah, it just adds, it makes it a pointer anyway. Oh right, we didn't start it. That's exactly what I suspected. Yeah, as you can see, the instruction got placed directly in between our overrides, which means it's getting overrode after we do it. Why? Just why? 132 entry point of road override, whatever. How to change correct entry point. Wait. What are you doing? And where does this go? I have so much confusion. Who is overwriting this? Are we too early? Hold on. I did not see... Oh, there it is. Now I need to know the load order. Because normally it's ntdll and then it's kernel 32. But there was something about the kernel base on 32-bit processors, if I recall correctly. The load order was just different. No, that's not what I care about. Windows 32-bit shellcode. Maybe that's helping. Without... Wait, what? Oh, it's doing a byte search. Cringe. Yes, yes. First module is the exe, second ntdll, and then kernel 32. Yeah, that's the same as with 64. Oh, the fourth is kernel base. Interesting. Pretty sure that's not the case for 64-bit Windows. He's using immunity. This might be pretty old, actually. Or maybe they are just old school. Not that it really matters a lot. Yeah, that's what I'm doing. Second and the third. Yeah, what is those guys saying? I remember reading this post to write my 64-bit shellcode. God damn it, I don't want to use Bing. Huh. That's kind of what I'm doing. Neat. Very useful to monitor. Modify its entry point. Yeah, that's exactly what I'm doing. Timing modification. Storing callbacks. Yes, yes. Getting main thread object. Alright. First parameter, eProcess, you can get the only thread of the process. What do I want with the thread though? Provides a method to register thread functions. Yes, yes, create session, create process, create suspended thread. Why? Notify process to create callback for the thread. Oh, is this using APC? No, I don't think it is. Change the thread context. Huh. Oh, here we go. Someone modified a trap frame, whatever that means. System sets the start of a new thread kernel as start user thread defaults to the start of the user mode module. Huh. Huh. It actually does modify it. Looks like. I have no idea what I'm looking at. But I do think that's a little bit hacky and too early. Because I want to inject once all the modules are loaded. But that is valuable information. This is gonna be so annoying. I'm just gonna take a break. Maybe read some more about what's going on with that thing. Hope you guys have a nice day. Goodbye.